In this video, we are going to look at tree diagrams and finding probabilities from tree diagrams. So we can draw tree diagrams to show the outcomes of two or more events when events happen one after the other. So our example here, so a bag contains six blue marbles and 4 red marbles. A marble is taken at random from the bag and not replaced. A second marble is then taken. We're being asked to find the probability that both marbles taken are different colours, and then the probability that at least one marble taken is red. So we're going to start off just with our tree diagram. So we're going to consider the first marble taken can be either blue or red. It is not being replaced, but then the second one taken again can either be blue or red. So blue and red. So we've got the basic outline of our tree diagram. Now, in the first instance, there were 6 blue and 4 red marbles. So that's 10 marbles in total. I've got 6 out of 10 blue and 4 out of 10 red. Now, importantly, we were told that the marbles were not replaced. So the probabilities on the second set of branches will depend on what has happened the first time. So if the first one taken was blue, there were 6, there must now only be 5. And also the total amount will have gone down since we've not put any back. And if 5 out of 9 are blue, the other 4 out of 9 must be red. Equally, if the first one taken was red, there were 4 red ones, there are now only 3, so that's going to be 3 out of 9, which means that the probability on this branch here must therefore be 6 out of 9. Now, to find probabilities along in a tree diagram, we can multiply along the branches. So as an example of that, the probability of taking 2 blue marbles is, so probability of blue then blue is going to be 6/10 multiplied by 5/9, which would give us 30/90. In fact, let's do that for all of these. So the probability of blue then red would be 6/10 multiplied by 4/9, so 6/10 times 4/9, which is 24/90. The probability of red then blue is going to be 4/10 multiplied by 6/9, which is 24/90. And finally, the probability of red then red is 4/10 multiplied by 3/9. So 4/10 multiplied by 3/9, which is 12/90. So we've got our tree diagram drawn and we've got the probabilities worked out for each of those sets of branches. So now, if I look at the questions we were being asked, question A is asking us to find the probability that both marbles taken are different colours. So if we think about it, the ways of taking 2 marbles which are different colours, we've got blue then red, they are different, and red then blue, they are different. So that question, it's going to be the probability of blue then red plus the probability of red then blue. So in other words, blue then red was 24/90. Red then blue was 24/90. And adding those together is going to give us 48/90. So the probability that both marbles taken are different colours is 48/90. for part B, we're being asked to find the probability that at least one marble taken is red. Now there's a couple of different ways we could do this. I could consider all of the options which have at least one red, so that's going to be these two because they have exactly one red, and also this one because that's both red. I could add those together in the same way I did these. Or we could recognise that the only outcome which doesn't have at least one red is the outcome where they're both blue. So this 30/90. And since all of these probabilities must add to 1, since they are the only things that can happen, to find the probability of at least one red from this, I can do 1 subtract the probability that they're both blue. Or in other words, 1 subtract 30/90, and that is going to give us 60/90. So that's going to be our answer to part B. And hopefully we can notice that if I did just take these three and add them, 24 and 24 is 48, plus 12 gives us 60. It gives us that same 60/90. That's the end of this video. Thank you so much for watching. For more A-Level and GCSE maths content, like and subscribe to N Jackson Maths on YouTube.